Hello, everyone. My name is Azeezah Acar, and I'm the Capstone team lead of the BikePed Portal Data Collection Automation Project. I'm joined by my teammates, Artem, Kevin, Hongzu, Alan, and Nick. This project was sponsored by Tammy Lee from BikePed. BikePed Portal is both a data management system for manual and automated pedestrian and bicycle counts and a database for these non-motorized counts. In its current system, much of the data is received through email as CSV files, which are entered manually into the system. The focus of this project is to streamline this process by enabling BikePed portal users to upload CSV text and Excel files to the website and automate the processing and inserting of these files into the database.
Hi there, I'm Nick Sinesky, and I'm one of the developers from Team Azeezah for the Winter 2025 Capstone. Our project was the BikePed Portal Data Collection Automation, which involved adding functionality to Portland State's very own BikePed website. Specifically, the functionality for authorized users to upload their data via file upload on the website directly, using its graphical user interface, as opposed to the old method, which used a scripting file. So let's go ahead and access the website and take a look at what was changed. Here we have the landing page for the BikePed website, and this is a local development copy of the website running on my machine. The website is running on the Django framework, a PostgreSQL server for the database, and the front end is written in the typical JavaScript, CSS, and HTML stack. I'll go ahead and log in and show what was changed. So here we have the account page for the user with pre-existing features like the dashboard and download data. You see, the BikePed website is all about storing and visualizing bicycle and other pedestrian traffic data from all across the country. The goal of this project was to help streamline the upload functionality to make it easier for website users to submit their collected data. To that end, an upload data interface was added, and clicking on this button right here loads the upload file interface. We can see two main sections, the upload file interface and the your uploaded files section, which displays previously uploaded files from the current user. As you can see, this user doesn't have any uploaded files at the moment, so let's go ahead and add some to the database. I'll select a few files here from my machine, which are in CSV format, but the system does accept Excel files as well. Now the uploaded data is formatted as traffic volume for a given date and time in a specific measure period, typically 15 minutes or an hour. Now as I select the files to upload, the code parses the files and displays the data in preview charts using the HiCharts library. It also displays information about the so-called flow detector, which is the measurement tool used to collect the traffic data in the first place. It shows things like location and segment name, the traffic flow direction, and what type of traffic the flow detector has. This preview feature lets the user inspect the data before uploading to see if there's anything amiss in their file, like missing dates, erroneous traffic volume data, or incorrect traffic flow detector IDs. If I change my mind about uploading a file, I can delete it from the list or simply toggle its visibility. When I'm done inspecting the chart, I can hit upload, and the website will attempt to insert and verify the data. Now, using JavaScript allowed me to code the interface in such a way that the page doesn't need to refresh after every form submission or file deletion, which makes the website feel a lot more responsive. So right now, this file is giving me an error about the flow detector ID. But let's go ahead and try uploading this file anyway. Any errors during the upload process are displayed here, along with a result message about the file upload. Here we can see the file was uploaded, but with warnings that I can view here in this collapsible error container. So we see a bunch of errors regarding that erroneous flow detector ID. Because the application wasn't able to correctly verify the detector ID, it didn't upload any rows with that ID, but still allowed the correctly verified data to be inserted. Now, at the bottom, under the Your Uploaded Files section, we can see the file has been uploaded and is pending processing. The sponsor requests that we give the user the ability to delete their data up to 24 hours after uploading. This gives the user a second chance to verify their data before the data is inserted permanently into the database. If the user so chooses, they can preview the data again and delete it from the processing queue if something isn't right. Here we can see only the verified data was allowed to be inserted. Now, after a 24-hour period, the file's data will be transferred into the main database, where it will be further processed by the application as normal. And that status will be reflected down here with a process status. That concludes the demonstration. Thank you very much.
This is Macdonald. Today I'll be going over the why and what for our Capstone project. BikePed's motivation is pretty simple. They currently receive much of their data in emailed CSV files. These CSV files must then be manually processed and manually added to their database. BikePed therefore wants a web page to have users easily upload these files, and then have these files automatically processed and added to their database. This tool will save a huge amount of time for BikePed portal and will make it much easier to expand their data set in the future. Another key motivation here is they want this to be a production-ready tool, so it must be robust with things like error checking and the ability to recall files within a certain time frame. To meet these needs, we've made a user-friendly upload page on the existing BikePed website with full database integration. 4 key features of this is the ability to upload CSV, text, and Excel files with count data, a data visualization to show what you're uploading, data validation to ensure the robustness of this tool, and the ability to commit validated data directly to the database after a holding period. The first key feature is upload files. You can upload up to 5 CSV, Excel, or text files at once, and we have a user interface to display the upload files and manually add or remove individual files. Our next key feature is file previews. For each file upload, we generate a data visualization to preview the count volume over time and what flow detectors are detected in each file and the associated information. This ensures that users are always uploading the data they intend to and that data seems correct to them. We have the ability to preview multiple flow detectors in a single file and multiple files at once. This ensures that everything uploaded is previewed and verified by the user. Our next key feature is automatic error detection. We have error detection for format and data errors. These errors are specific to a file, and some errors are even specific to rows in that file. For example, over here we have an error in this file, row 3, there is a negative volume, which can't happen. So these errors are displayed to the user, and files may be rejected to ensure the integrity of their database. We also have the additional option for files where errors are limited to a specific row to upload the files without these rows. Our last key feature is database processing. We have a queue of files that are uploaded once that the user can interact with and remove at any time before they are processed. After 24 hours, these files are processed into BikePed's existing database. This ensures the data added is fully compatible with BikePed's existing structure. For any other features, our main focus was making these core features robust, user-friendly, and good-looking, which we believe we've done. In terms of other features that aren't these key features, a big one is just visual consistency with the rest of BikePed's website. This upload page is entirely new and fits right in with the rest of the website. Thank you.
Hello, my name is Artem Suprun, and I'll be covering the architecture portion of this presentation. In the following slides covered by me, I'll be explaining how the system works and its overall implementation. Starting with a high-level overview, in this section I'll explain the main parts of the architecture in a high-level point of view. This slide is aimed for those who don't have a very well understanding of the system. Since the program is a web application, the system follows a client-server architecture. When users upload a file or files to the server, it will be sent directly to the backend, where the request will be properly processed. Users won't be sending their files directly to the backend or the database. It will only be to the frontend. The backend handles the communication between the frontend and the database, which means users will only communicate with the frontend. In brief, when a user sends a request, it will be done through the front end of the component, and that part will only be able to communicate with the backend. From there, the request gets processed by the backend. The backend will either save that information given by the user or pull certain information out of the database requested by a user and sends it back to them. On to the next slide. This slide contains more information about how the system works and what tools are used. The main point of interest is that this system uses the Django web framework, which allows us to use its many great built-in features that it has, specifically the security aspect of the program. The Django handles many of the security aspects that come with running a dynamic website, which is helpful in reducing the time spent in development. And since the system uses Django, the entire application follows the model view template architecture, which is its design pattern. Models are seen as database structures which represent a point of interaction between the backend and the database. Onto the views component, when receiving a web request as shown in the diagram, with the user sending a media file, the views handles the logic of the web application. This component handles the communication between all parts of the system and is also responsible for sending responses back to users. Finally, the template component is used for rendering the dynamic web page in a website. Given the diagram, we can follow that when the user logs into their account and decides to upload their file, the view will request a dynamic web page from the template, which will be sent to the user. And once the user decides to upload their file and send it, the web request goes directly to the views file, where the file gets validated and verified. After it's thoroughly processed and no issues were found, the file's contents gets saved into the database with the use of a model. Once things are saved, the file status is sent back to the user by a JSON response, which is handled by the web page's JavaScript. Finally, onto the implementation of these features. I've separated them into two categories, which are mainly based on where they've been developed for. Things in the backend section were developed for within the backend, and things in the front end were developed within the front end of the application. Starting with the backend features, the pending file upload feature is handled by a Python Celery task, which is called upon once a file is uploaded and saved to the database. This task ensures that the file is properly saved to the database once the 24-hour mark is passed. The multi-file upload feature is handled by a forms that was built using the Django's built-in tools, and which helps in verifying that multiple files are in proper format. File validation verification is handled in the views, forms, and models of the program. And on to the front-end features, starting with the upload web page, which uses the built-in Django template engine in helping creating a dynamic page, and is designed with the Bootstrap framework. And finally, the file preview feature, which uses the JavaScript HighCharts library to display file previews. The JavaScript file can be found in the static folder named data_upload.js.
This is Azeezah, and I will be covering the development process. During this project, we utilized the Agile software development methodology. As for project management, we used Jira. For version control, we used Git. Specifically, we used GitHub, as that was what the code base was previously on. And for communication, we used Discord, Zoom, and email. Discord was used between team members, both for meetings as well as other communications. Email was used on some occasions as well. Zoom was used for meeting with the sponsor, and email was mainly used to contact the sponsor. As for how we conducted team meetings, we had stand-up meetings in which team members would brief the team of what tasks they have selected, what they have completed, what they're working on, and if they did, what roadblocks they faced.
Responsibilities and contributions. As a team, we held weekly meetings on Monday at 6:30 p.m. and we used Jira to plan and assign tasks and feature creation. Having weekly meetings helped us plan our next steps and assess how the project was coming along. It helped us determine whether people were running into any issues or not and decide what features to work on next. Initially, we planned our own tasks, but it was hard to coordinate since some members got started more quickly than others, and were working on features without declaring it to the rest of the team. So later we decided to declare what we were working on in Discord to avoid working on the same feature. We made this change because I worked on the deleting pending files feature, but Nick was working on it during the same week, so we decided to keep his implementation and remove mine. They were very similar, so it didn't make much difference to the outcome of the project. Nick put in a lot of work on this project and got a lot done. He got started looking over the code during spring break and was able to get our first features implemented, which included the basic upload functionality and a preview of the data with bar graphs. Throughout the term, he fixed bugs, added the original functionality to hold the files for 24 hours before processing, enabled multi-file previews, and added an error page container as well as a list of uploaded files that belong to the current user that is logged in. I, Alan, got a fair amount done. My first contribution was adding an npm root path, which allowed the website to run much faster locally. I also cleaned up the settings file to make sure we weren't adding extra code that could interfere with the production environment. Later, I worked on the file deletion, but that didn't get implemented due to the delegation issues. After that, I added text and Excel file uploading functionality and implemented insertion to the uploads table with a celery task. Artem had significant contributions, including multi-file uploading, some code cleanup, and code review of Azeezah's work. Kevin also contributed a lot, once he became comfortable with the codebase. He retrieved and displayed flow detector IDs from uploaded files, added a new endpoint, improved error detection and display, and fixed other bugs. Azeezah contributed quite a bit to the team. Being the team leader, she set up meetings with the sponsor and led our team meetings. In addition to the logistical work, she built the volume and date-time validation code. Hong contributed to data validation as well. He added measure period validation and column validation.
One of the unexpected issues we faced during the initial setup was that some libraries didn't install properly. Even though we followed the official instructions, we later discovered that the problems were mainly caused by Python version mismatches and the conflicts between library versions. In some cases, the installation failed silently, or incorrect versions of packages were installed, which made it difficult to debug. Additionally, some team members remembered that the libraries were not getting installed into the expected lab folder by default. They had to manually move them into the correct location until they made changes in the code to fix the installation path. It also seemed like different team members experienced different installation issues depending on their operating system and Python version, which made it harder to establish a consistent setup process across the team. To fix these issues, we reviewed the required library versions, updated the requirements file, standardized on a compatible Python version, and used virtual environments to isolate dependencies. After these adjustments, the environment setup became much more stable and reliable for everyone.
This is Azeezah, and I will be covering sponsor feedback and lessons learned. We asked our sponsor, Tammy, a couple of questions regarding their plan for the software and her experience with Capstone. Our initial question was about their plans regarding the software. And based on our previous conversations and her response to the question, it appears that they will be deploying the code to a staging server where users will get to test it out. And if they think it needs any more modifications, they will do such modifications and then they will deploy this modified version to the live site. The other question we asked was regarding her experience of Capstone from her perspective. And given her response, it appears that Tammy was satisfied with her front-end design as well as our flexibility with making changes to the code base when she requested or came up with a new requirement. There were many lessons that we learned during this project. However, there were a few that we thought were more important than the rest. The first is the importance of a detailed environment setup. Having clear descriptive instructions on a project on how to set up a project environment is important for helping developers to get started on the program as well as setting up a working environment. This prevents issues from popping up later on during the development process. The second is on coordination. I want to make 2 points on this. Coordination takes time. It's not something that can be set up perfectly right from the start, especially when it's your first time working with your teammates. The second point is more positive. Coordination gets easier as time goes on. As you get more familiar with your teammates, coordinating with them becomes easier. The third lesson is on communication. I also want to make 2 points regarding this. The first is that there's a limit to what can be conveyed through asynchronous communication, such as email. Since it takes more time, it's harder to clarify statements that are unclear. As such, asynchronous communication, such as Zoom meetings, are better, especially for requirements gathering. It's easier to clarify unclear requirements and statements as you're in a live meeting. You also receive feedback faster. This makes it easier to collect clear and more precise requirements that fit the sponsor's needs. Thank you. I want to end this presentation by giving special acknowledgement to those who made this project possible. Our sponsor, Tammy. Thank you so much for sponsoring this project and for giving us the opportunity to contribute to BikePed Portal. Bruce Irvin, our Capstone supervisor. Thank you for patiently guiding us along the way and for providing the necessary tools for our success. And finally, I want to thank my teammates for being cooperative and supportive of me and for giving me the opportunity to work alongside them on this project. Thank you all for watching our presentation.